This evening on construction, mechanics, and electronics, I'm going to be setting up an ESP32 dev board to act as a wireless access point and to also act as an HTTP server so that it can parse HTTP requests from a device that tries to access a specific URL while it is connected to the network that this dev board is providing, and parse those requests in order to turn on or off an LED light. Let's get started. So first things first is the code, and I got this code from off the internet. Basically, it includes 3 different libraries that allow the ESP32 to handle, Wi-Fi connections, acting as an HTTP server, and also acting specifically as a Wi-Fi access point. And then I'm setting the pin mode of LED built in, which I've defined up here, as well as the pin mode for pin 22 as outputs. And then this portion right here where it says serial begin, serial print, that's so that whenever I bring up a terminal here in the Arduino IDE, I can basically see what it's doing, see if it's working correctly. But the actual part of the code that does the work that we're interested in is right here. And basically, if we're using if statements, if current line dot ends with get h, so basically when I access this Wi-Fi access point, you may have heard of this like on your own small office or home office network, but you're accessing your default gateway. So that's like the URL or the website address or the IP address of the router itself, the actual router in your house. And for a lot of small office, home office networks, it's going to be 192.168.1.1 or something like that. It's a Class C IP address. Well, anyway, if you actually open up a web browser and you type in that IP address, then it'll actually take you to a page that is displayed by the router. And usually that's how you set up your settings for your router, like changing the password or limiting when certain devices can and can't access. Like if everybody's got a bedtime in the house and you don't want anybody on the router after, let's say, 11 p.m., then you could set limits, and that's usually handled by the router itself, which is also doing the same thing that this ESP32 is going to do. It's acting as a wireless access point. But what these if statements right here do is they basically cause the ESP32 to parse those requests. So, if I go to a website, which this is basically a website, 192.168.1.1, then this is sort of like a sub page of the website. So just like if I go to google.com and then I click on image search, it's google.com/images or whatever. This is also kind of a sub page of the website that's being provided as a web server by this ESP32. So I go to /h, and just the request for that page is actually what tells the ESP32 to perform a digital write to LED built in high. So I'm turning the LED on. And if I make a request 192.168.1.1/L, then it's going to turn the LED back off again. And I will demonstrate this after I show you how the breadboard is set up. Now, the first thing I like to do before I set up the breadboard with the components I'm going to be using is I actually like to go ahead and program the board right now. So because right now this board, I may have used it for another project, and I don't know how these pins are wired up. I don't know what each of them are set up to do, and if I hook up a component and it's set up to do something different than what I think it's set up to do, then I might fry something. So what I like to do is I like to actually program the board first and then unplug it, make all the physical connections, and then plug the board back in, and it should be working. And as you can see right here in the bottom right, it says compiling sketch. And let me just make sure that I'm connected. Yep, ESP32 on COM6. It's going to compile that sketch and it's going to load it. And you can see right here how the sketch is finishing up. It's basically writing in hexadecimal, or at specific registers which have a hexadecimal address, all of the data that the ESP32 needs in order to do this. So now that I have my ESP32 programmed, what I'm going to do is I'm going to go ahead and unplug this, and I need to know, where is pin 22? Now, each pin is numbered, but there is a physical numbering convention, and then there's also the GPIO, or general purpose input output numbering. And to get that, what I can do here is I can go to my hobby reference folder here, and I can go to the ESP32 pinout, and as you can see, anything that's kind of like beige colored, that's going to be your GPIO pins. So I want 2 and 22, and I think 2 is actually an internal circuit, yeah, because I see 1 and 3, so that might be for models that have a built-in LED. Mine, I'm going to be using, oh, okay, here it is. So GPIO 2, and then I can also use, if I can find it, GPIO 22, if it's available, which is going to be right up here. So now that we know where pins 2 and 22 are, as well as where our grounds are, we can begin the process of wiring this up. So what I've got here now is I have the ESP32, and you can see that I've got a white wire coming from pins 2 and pins 22 going over to these 2 rows over here. And each of these rows that go this way are all connected together. There's an open at the space in the middle, and then each of the rows on this side are also connected. So the output of this resistor is connected to the input, or the anode, of this blue LED, and the same for this red LED, except with this resistor over here. So I have 2 220 ohm resistors that the current is going through before it goes to the LED. And the reason we need 220 ohm resistor for an LED is because even at 3.3 volts, you know, once you get an LED forwarded, once it opens and it's conducting current, it does so with very little resistance. So if you just run an LED with a battery or with a microcontroller or whatever, and you don't have an inline resistor, then you're basically creating a short to ground from power. And we don't want to do that because we don't want to have an overcurrent issue happen with our board. And then the cathode of each LED is connected to one of these 2 power bars, and it's actually connected to the one on the top side here, this blue line. And that bus bar connects back to one of the ESP32's grounds. So now what's going to happen is I am going to go to my network connections, and I'm going to disconnect from my home network, and I'm going to attach to this network, and I don't know if you can see it right here, but it's labeled your AP, your access point. And I'm going to connect to this, and for the password, it's just going to be your password with a capital P. I'm going to hit next and do all of that, and it's going to connect to this ESP32. So basically my laptop is connecting to the ESP32 like it is a router, basically. And this might take a minute here because I'm not sure if Windows is gonna say that it's not a secure connection or whatever. But okay, so it's connected, and we can see that it says no internet, but it is a secured network. Well, if I go to the default gateway, 192.168.4.1, and I hit enter, then it brings me to this page right here where I have these two little hypertext links. And it says click here to turn on the LED, and when I do so, it turns on the LED. And it also has another little bit of text right here that says click here to turn off the LED. So I click here to turn off, and mind you, I know that I'm powering the ESP32 with my USB port here, but the computer is not talking through this cable and telling the ESP what to do. What it's actually done is it's connected to the ESP32 as if it was a router. And by the web page requests that I'm making, it is doing that. Now, let me see if I detach my keyboard here and I go a little bit closer here so you can actually see what I'm doing. And really what it is let me switch to tablet mode so I can actually get the little keyboard to pop up here. So if I hit backspace, really what it is it's the HTTP requests. It's the actual request for 192.168.4.1/H. And when I make that request and I hit enter, that's when it turns on the red LED. And then there's two more that weren't provided in the example sketch, but I added them after the fact. So if I go to /P and then I hit enter, then it turns on the blue LED. So you might say, well, what is this useful for exactly? Well, let's say I wanted to make a garage door opener, and let's say that the garage door has an open and close button, but and it's like actually physically attached to the wall. But I want to build a remote for it. Well, I could actually just conceal this little ESP32 microcontroller in the junction box or the service box that holds the switch, and I could have this running, have it powered, from a wall wart, basically, have it running at all times, providing a network that says garage door. And I could connect to that network, garage door, with my phone, and then I could go to 192.168.4.1/H, and I could open the garage door. So what this does is it basically gives you the ability to make something remote control. And that's what's really cool about these dev boards, is that they allow you to add functionality to things, even if they're older technologies, but give you the ability to open and close a garage door from your phone, or turn your coffee pot on from bed as you're getting out of bed, whatever.